Adding radicals. Put the other worksheet up or I will throw it away. And you will get a 0. Adding radicals. This is simple, simple, simple. The properties to adding this. Do we all know how to simplify this expression? How would I simplify this expression? What are my like terms with 3x?
3x and 8x, 4y, 2y.
What would be my answer?
11x plus 6y.
Shh, I didn't ask anything. Just write it down. Blake, wake up. You're right-handed, right? So how could you be writing down if your right hand's right here? Gotcha. Anyhow. Can anyone tell me what seems similar about these two expressions here and here? What's similar? Yes.
Like with the x's on the top one, it's kind of like in the radical, the 2, and the 2, and the 3, and the 2.
Okay. What? Someone else. So what you're saying? Say this to me again. Simplest way you can say it.
How it has the x's and the y's up top.
Well, just where it has an X up top. What does it have at bottom?
2.
No, it doesn't. That's not a 2.
Radical
It has yeah. That's not a 2. That's a square root of 2. Very important. It's like saying, I'll give me $10 or give me 10 divided by $2. Which one's a better deal?
$10.
Okay, I still had a 10 in both those, right?
Yeah.
One was 5 and one was actually 10, wasn't it? Point I'm making is, okay, so you're saying where there was an X up here, there's a what?
Radical 2. And when there's a y, there's a radical 2.
Question is, do I treat these the same way I do here?
Yes.
The answer to that question is yes. Think of the square roots as like apples or oranges, just like you have 3 apples, 4 oranges, 8 apples, and what? 2 oranges. You had what? 11 apples and 6 what?
Oranges.
This is no different. The like term to this, what's a like term when adding radicals? I have 3 square roots of 2 here. See how you're kind of saying you have 3 of this when the way I say that to you? The thing that would make sense, if I had 3 square roots of here and 8 square roots of 2 here, how many square roots of 2 do I have? I have 11 square roots of 2, just like I had 11 what? X's here. I have 4 what? Square roots of 3 here. I have 2 what? Square roots of 3 what? There. I have a total of 6 square roots of. Did I change the number underneath here? No. That's like a unit, inches, or x's, whatever you may be. You can only add them if they're exactly the what? Same. Exactly the square root and exactly the same number under the square root. So do you think I could add 3 square roots of 5 plus 4 square roots of 2? I couldn't, could I? They're not like terms. That's just simplified. That's already simplified. So does that make sense? So if they're like terms, it's easy to do. However, an expression is never simplified unless each radical is simplified. This is your one rule about number 1, 2. An expression is never simplified unless each radical is what?
Simplified.
Now, everybody look at this. Are all eyes up here? Or we have it, we still writing down the, do I need to give you one? Okay. Right now, do I have any like terms? No. But you can't just say, okay, I'm done. You have to make sure each radical is simplified. What's the largest perfect square that's a factor of that? Well, I already wrote down all my perfect squares over here, didn't I? So I need to say, what's the largest perfect square? It's a factor of it. Half of it, and I'm going to go through all of it, is what? 48? 48 is not a perfect square, is it? 49 is. Well, 36 divide into it evenly. 25? 16?
Yes.
So it's square root of 16, because there's my perfect square, times square root of what? 16 times what is 96? 6? Plus, now let's simplify this. Is that simplified? What's the largest perfect square? It's a factor of it. Well, half of it's 12. Will 9 go into it? Will 4 go into it? How would I rewrite it? Square root of 4 times, square root of 4 times what is 24? What is the square root of 16? So this becomes 4 square roots of 6. Guys, watch. Don't write. Pay attention. Make sure you know what we're doing. Sometimes you guys get so much into writing, you're just writing. You're not really listening. And it's important that we do. Does everyone understand that this square root of 16 became 4? Yes. Does everybody understand that the square root of 16 became 4? Do we see how we simplified this? And then that just brought down. Plus, what did the square root of 4 become? So now I've simplified each one. Now am I done? Because it turns out, I mean, they didn't look anything like close to like terms here, did they? But once I simplified each one of them, that's a square root of 6 term, and that's a what? They combine to be what? 6 square roots of? Interesting, huh? So do you see why now you have to simplify each square root? Yes.
How come in some of the problems from yesterday, you would put like, okay, we went back to 16, for the square root of 16 times square root of 6, you simplified it down to 4, but then you put times 4 and make it 16. You know what I'm saying? Like, you did that.
Like if there was a,
There's one on the outside of the radical.
you talking if there's one out here?
No, like on number 1, you did that yesterday. We got it down to square root of 4 and square root of 6, and you did.
It should have been 2 square roots of 6.
Well, then you told us to do 2 times 2.
I think that's when I made it into a product of primes. Or I broke it down and I didn't find the largest perfect square that was a factor of it. See, for instance, on square root of 96, I could have said, okay, I bet 4 will go into that. How many times does 4 go into that divided? No, 20. 4, right?
4, yeah.
Okay, so that became a 2. I was just showing you guys that, you know, if you don't pick the largest perfect square, you can still eventually get it simplified, as long as you just keep bringing everything down. 2 times, what's the largest perfect square? It's a factor of 24. 4 times square root of 6. See that right there? That still stays 2. What does that become? 2 times square root of 6. What do you get here? 4 square roots of 6, right? What I was trying to show you guys is that if you happen to accidentally pick the perfect square that's not the largest factor of it, as long as you keep going, you'll eventually end up with the same answer, won't you? That's what I was trying to teach you yesterday when I did it like that.
Always try to simplify.
You just keep trying to simplify it down. Only way you know you're simplified is if the number under the square root, if the largest perfect square it's a factor of it is 1, then it's simplified. And think about it, 4 won't go into 6. 1 is the biggest perfect square it's a factor of it, so it's you know it's simplified. Now, everybody think we can do that?
Yeah.
So it's basically the stuff yesterday, then adding like terms, right? Okay, we got to go on to something else that some may consider a little harder, but it's something we have to cover. And it's something you've done before. It's just, I don't know if you remember it. You should have done this in Algebra 1. First of all, square root of A over square root of B. What did we talk about that's the same thing as? Square root of what? A divided by what? So you can put them back underneath, right? So, for example, if I had square root of 10 over square root of 2, can I divide those two? Don't write, watch. Sorry. Can I divide those two? Because they're both under the square root, this is base of square root of 10 over square root of 2. What is the square root of 10? 10 over 2. Or what is 10 divided by 2? This equals square root of what? How easy was that? What do you not get? Basically, you follow this right here. If both of them are under a square root, you can combine them into one square root, right? That means that divided by that. So that's all I did. I saw in my head that 2 goes into that what? But it goes into its square root of 5 times. You see what I'm saying? My suggestion to you is when you have a problem like this, and I'm going to tell you why here in a second. First, make sure if they're both under the square root, make sure it doesn't reduce some. It'll make your life easier. Will 6 go into, what number will go into both 6 and 8? So this is square root of 2 over square root of what? I'm sorry. It's just 2 over what? 3 will go into that 2, or 2 will go into that 3 times, and 2 will go into that what? So it's square root of 3 over square root of what? What is the square root of 4? So it's square root of 3 over 2 is your answer right there. Okay, that's how you'd simplify that. You need to remember that you can put them all under the same one or, have them separate, right?
Wasn't there something like you could have like a radical?
We're getting ready to get into that.
Yeah.
The reason I say this is reduce this all the way down. You may not have to rationalize the denominator, which is what it's called. But there's a big rule. An expression is also never simplified if there are any radicals in the denominator. What's the denominator? Bottom of a, you can't have a radical in the bottom. So what do? Just give up when there's one there? No, I'll show you how to always get rid of it. And these problems I did up here, you could have just rationalized the denominator from the start if you wanted to. It would have made it longer and harder, but it would still work. Once everybody gets to this point, put your pencils down, and I'm going to explain how to do that. Okay?
Coach Stock, is it ever possible to have like a negative number outside the radical?
Outside of it and inside, but it just becomes a complex number called imaginary numbers.
Will we have any notes of the number one that you just wrote on our worksheet today?
Yes. You guys want to write it down? Which part? You're. How did I get the square root of 3 over 2? Okay, first thing I did is I realized that that fraction can reduce. Okay, I said to myself, 2 will go into that 3 times, and 2 will go into that 4. So I made 6 over 8 into what? 3 over 4. It's still all underneath the square root. Really, when you're reducing things, you don't want to have a whole fraction under a square root. You might think of them being both underneath it so you can reduce it, right? But then once you're done reducing it all the way, you need to split it back up. For this reason, what was nice, yes, that's not a perfect square, right? But then square root of 4, is that a perfect square? What number could I square and get 4 as the answer? The answer is? I can't answer that question, so it stays square root of 3, but I could answer that, so it goes to what? 2. That's why you always want to split it up, even if you put it back together. Now, when doing a problem like this too, guys, you'll find that as you go farther on in the math, you start doing things, you're just going to say to yourself, square root of 3 over square root of 4, instead of, not necessarily writing this down. Does that make sense? This is one of those things that you kind of know in your head that works, and that's why you can what? Simplify it to that. If they're both under the square root sign, you can multiply and you can divide them.
I thought 6 was completely triangle. I thought that.
That has nothing to do. Square root of 6 divided by square root of 8. See, that's what I'm trying to tell you. I reduced that fraction.
Okay.
Since they were both under the square root sign, I can make that square root of 6 over 8 is square root of A over square root of B is the same thing as saying square root of A over B. So I reduced the fraction, then split them back apart. Okay? Not necessarily, no. But what I'm saying is if you have both things under a square root and it looks like the fraction will simplify, or like this one, they'll divide, do it. It'll make life easier on yourself. But you have to remember they're both still under the square root sign. Everything is. So that's when we get to this. What am I going to do here? Will 3 over 2 simplify? No, it won't. And you don't want mixed numbers here. They're useless.
Can you times the bottom?
Well, here, I'm going to show you how to get rid of this. So right now you'd say it's simplified except for one thing. You can't have a square root at the bottom. Well, this is all based on the premises that square root of x times square root of x will always give you what as an answer? X. Remember we did this yesterday, square root of 3 times square root of 3. What's your answer? Square root of 9, which is? Square root of 100 times square root of 100 will give you what as an answer? Without the square root sign, right? Each time, in essence, don't write this down, what am I doing? I'm getting rid of the what? Square root. Anytime I multiply it times what? Itself. Where do I not want the square root to be? Here.
On the bottom.
So if I multiplied it by square root of 2, what would I have on the bottom?
2.
That would get what I wanted, right? Here's the thing, though, and don't write this down. Can I just do anything I want? No, I need to change this. I need to keep everything the same. Fractions are like equations. If you do the same thing to the bottom that you do to the top, you're okay. So if I multiply the bottom by square root of 2, to keep everything the same, I have to multiply the what? Now, what this is called is multiplying by 1 in concealed. I don't know if I spelled that right. Form. Because isn't that basically 1, the same thing divided by the same thing? Would you guys agree with that? The same thing divided by the same thing will always give you 1 as an answer. Whether it's Rachel divided by Rachel or Parker divided by Parker, the answer is what? 1. The same thing divided by the same thing is always 1. Clements. Clements! Slap him. So I basically just multiplied by 1 and I get the same thing back, right? So I multiplied the bottom by square root of 2, so then I have to multiply the what? Top by square root of 2, so I get square root of what? 6 on top. Now, what you always have to remember, is there any more simplifying to do? Because a lot of times when you multiply radicals, you make that number bigger and there's a chance it could be simplified, right? But square root of 6, what's the largest perfect square? It's a factor of it. Is 6 a perfect square? Largest perfect square, it's a factor of 6 is 1. So it's simplified. Now, your first thought here, and guard on this, is to say, ooh, 6 divided by 2 is 3. Is that a 6? That's a what?
Radical 6.
Much different. I can't divide these unless they're both either under or both what? Outside of the square root.
So there's no.
So guess what? You're done.
So if you had a number outside the radical, would
You
that
could
be
reduce, and we'll do one like that. Let's do another example. Blake, look up. Now, you don't have to write this down here, but here's how you need to think of this problem, okay? Isn't this basically 2 over 5 times square root of 5 over square root of 2? Everybody look down here and just pay attention. Isn't that the same thing as that? Okay, so when you're looking at this and you're trying to figure out if there's anything to reduce before you start messing with rationalizing the denominator, look, will that fraction reduce? Will that fraction reduce? So now the only thing left to do is what? Rationalize the denominator, right? I can't have a square root in the denominator, so multiply by itself. Now, what's the itself here? I don't care about this 5, do I? Just the what? Square root of, it's not a 2, it's a square root of 2. I don't want it to be there, right? So if I multiply that, I get rid of this, and that becomes a 2, doesn't it? But I have to remember, this is 5 what? Times square root of 2, right? So what's still here? 5 what? If I multiply the bottom by square root of 2, what do I have to multiply the top by? What's square root of 5 times square root of 2? Square root of? And what else do I bring on? You guys see how I'm to here? Any questions? Chris, bring your phone up here. 2 square roots of 10 over, what is 5 times 2?
10.
Now, maybe you'd have seen you could cancel out there. But see, this is what I mean, that sometimes, first of all, that won't reduce anymore, will it? But will 2 over 10 reduce?
Yes.
2 goes into 2 one time, goes into that what? So your answer is actually square root of 10 over what?
Wait. How did you get rid of the 2? Why did you get rid of the
Because 2 over 10 is not a reduced fraction. 2 goes into 2 one time, 2 goes in, you see how I could reduce it? Now if you look right here before you combined everything, right? That's basically what you did right there.
Same answer.
Yeah, you would have gotten the same answer. So how do you get rid of the square root at the bottom?
Multiply by the same.
Multiply by itself.
But what I'm confused on is, why wouldn't you, if you wanted to get rid of the square root sign on the top, why wouldn't you?
I'm not trying to get rid of it on the top.
Oh, yeah, just on the bottom, okay.
It's just on the bottom. Okay, everybody look at this one. I'll leave it up there so you can write it down. One more, because I want you to have some time to try it yourself. Will that fraction reduce? No. So, I need to get rid of that square root. How am I going to get rid of it? Multiplying it by itself, which is square root of?
7.
Multiply the bottom by what? Square root of 7. Multiply the top by square root of what? 7. Okay? What is square root of 7 times square root of 7? What is square root of 6 times square root of 7? Square root of, don't forget square root of. Now, You might look like you're done, but does that look like a number we need to investigate and make sure there's not some simplifying we can do? Okay, so let's do that. 6 times 7 is 42. Will 4 go into it? No.
Wait, I thought you did.
Will 16 go into it?
3 will.
Yes, I think 16. Is it 16? No,
Yeah.
not 16.
No, 3 will.
3's not.
Isn't it odd that that one won't reduce anymore?
That's it?
Think about it. The factors of it are 2, 21, 6, 7. None of those. 14 times 3 is 52.
Hold on, so if you end up with
Oh, 14 times 3 is
42.
42, but is 14 or 3 a perfect square? It won't reduce. There's no perfect squares besides one that are a factor of it. If you went through all of them, you know, think about them. We've got them on a sheet here, wherever that sheet is.
Right here, guys, we lose 1.
Hey. 4 won't go into it, 9 won't go into it, 16 won't go into it, 25 or 36. None of them will go into it. So, guess what? Even though it's a pretty number, we'd say, you know, if you know, usually you're expecting things to not be able to reduce to be an ugly type number. Gabriel, can I help you with something? Okay. It doesn't reduce.
So if you end up with like radical 15 over 3, you're wanting us to reduce the radical 15 even more, or just leave it as radical?
That doesn't reduce anymore. First of all, you can't divide those, right? Because this is outside of the radical, this is inside, right? What's the largest perfect square? It's a factor of 15. 9 won't divide into it.
So we're not going to simplify.
Well, 4 won't divide into it. 1 won't divide into it. However, what if you had this? We'll go get another one. What if we had square root of 18 over 3? That looks like it can't reduce because this is outside, this is inside, right? Does everybody see that? But what is square root of 18? Will a perfect square besides 1 go into that?
Yes.
What is it?
2 and 9.
Square root of 9 times square root of what? All of that over 3. What is the square root of 9?
3.
Now we have 3 square roots of 2 over 3.
Then it'd just be square root of 2.
See what I mean? So sometimes it won't even look like like right here, you know, it wouldn't jump out at you that these are necessarily reduce, would it? But you always have to make sure, like the 2 rules we learned today, for it to be simplified, what? Every square root is what? Has to be simplified, and there can be what? Not on the bottom, a radical. An expression is never simplified unless those 2 things are taken care of. Okay? Once again, square root of 8 over 6, let's say. Right now, that doesn't look like it can be simplified at all. But when I make this square root of 4 times square root of 2 over 6, what does that become? 2 square roots of 2 over what? 2 goes into 2 one time, goes into that 3. It's actually square root of 2 over what?
So if there is a
See what I mean? And I'm done because what? First of all, square root of 2 is simplified, and is there a radical on the bottom? No. So I am simplified. I am done. Yes,
So if there is just a 1 on the outside, should we not show it?
I wouldn't. Now you see your worksheet you have, and like I said, guys, I'm not trying to make this Algebra 2 and get into really, really detail with that. But the things we're going to do, you need to have an idea of being able to add like terms and deal with radicals. When we start getting into trig functions and things we're going to get into next in the chapter 8, you have to be able to simplify a radical. You need to be able to know how to multiply radicals. Okay?
You want to do one problem on the front, one problem on the back?
No. Tomorrow I maybe can. After you guys have tried it. How about that?
So do you
Deal?
want us-
After you guys have pretty much got it all done tonight, I'll do one example from the front, one example from the back tomorrow.
Wait, what if there's a negative in it?
Where are you going to learn more? Me doing it for you, or you figuring it out?
Us figure
Bull. You trying it, and then after you've tried it and maybe you made a mistake, me correcting you and you see where the mistake is. I respectfully disagree.